Hello, friends. Disclaimer. As an Amazon associate, I earn from qualifying purchases at no additional cost to you. Please don't forget to check out product links for stargazing at the end of this video. Imagine a reality where every decision you make creates an alternate world, each one existing simultaneously with your own. This concept is more than just a thought experiment or science fiction. It's rooted in theories from quantum mechanics, cosmology, and philosophy. In this video, we will delve deep into understanding the 9 types of multiverses proposed by modern science. We'll also explore how these ideas have evolved from ancient philosophies, consider the scientific debates surrounding them, and use thought experiments like Schrödinger's cat to clarify these complex concepts. By connecting these ideas with other branches of science and speculative fiction, we'll build a comprehensive understanding of how the multiverse theory has developed from early speculations to the forefront of cutting-edge physics. The concept of multiple universes has deep historical roots. Ancient Greek philosophers like Democritus and Epicurus were among the first to propose that if everything is made up of tiny, indivisible particles, then infinite worlds could exist. These worlds might resemble our own or be entirely different, with their own configurations of matter. In Hindu cosmology, the concept of lokas introduces the idea of parallel realms that coexist with our own, each governed by unique laws. These early ideas, although philosophical and metaphysical, paved the way for later scientific discussions on the possibility of multiple realities. During the Renaissance, the Italian philosopher Giordano Bruno revived and expanded these ideas. He suggested that the stars we see are suns like our own, each with its own planets and potentially life. Bruno's radical belief in an infinite universe filled with countless worlds eventually led to his execution, but his ideas influenced the future exploration of the cosmos and the possibility of multiple universes. The development of modern science in the 17th and 18th centuries focused on understanding the laws governing a single universe. Figures like Isaac Newton and Johannes Kepler concentrated on explaining natural phenomena within one consistent framework. However, in the 20th century, breakthroughs in quantum mechanics and the theory of relativity reignited discussions about the possibility of multiple universes. Concepts like superposition and the weird behavior of particles at the smallest scales led to the famous thought experiment of Schrödinger's cat. This experiment helped introduce the many worlds interpretation, where every quantum event creates a new universe, branching off into separate realities. The quilted multiverse is based on the idea that if the universe is infinite in size, then it must contain an infinite number of regions. Our observable universe is just a tiny fraction of this infinite space. Think of the universe as an enormous patchwork quilt that stretches endlessly in all directions. Each patch represents a different region. Given that there are only so many ways particles can be arranged, some of these patches will be identical or nearly identical to ours. This means that far beyond what we can see, there are exact copies of you and me living out similar or slightly different lives. In one of these regions, your life might be almost the same as it is now, except with one small difference, like choosing a different career or living in a different city. The infinite nature of space implies that every possible arrangement of particles is repeated somewhere, creating countless parallel universes that are almost but not quite the same. The inflationary multiverse arises from the theory of cosmic inflation, which describes how the universe expanded rapidly right after the Big Bang. This period of inflation was so intense that it created regions of space that grew at different rates. Imagine that space is like a frothy foam, where each bubble represents a separate universe. In the inflationary model, Our universe is just one bubble in a vast cosmic foam, and there are countless other bubbles, each representing its own universe. The key idea here is that inflation didn't stop everywhere at the same time. In some regions, inflation continued, creating more and more bubbles, each forming a new universe. These bubble universes are isolated from each other, so they can't interact. What makes this model fascinating is that each bubble universe could have completely different physical laws. In one bubble, gravity might be stronger. In another, the speed of light could be different. This leads to the idea that there could be universes out there with completely different rules of physics, where life as we know it might not even be possible. The brain multiverse comes from string theory, a field of physics that attempts to explain how everything in the universe is connected by tiny, vibrating strings. In this model, our universe is a three-dimensional brain, a kind of membrane that floats in a higher dimensional space. Think of our universe as a flat sheet of paper. But instead of just one sheet, there are many sheets stacked alongside each other. Each sheet represents a different universe. These brains can move and sometimes even collide with one another. When they do, the energy from the collision could trigger the birth of a new universe. This theory suggests that there could be an entire stack of universes, each existing parallel to our own, but we can't interact with them because they're confined to their own brains. In this model, some of the mysterious forces we observe, like dark matter or gravity, could be the result of interactions with other brains that are close to our own. The cyclic multiverse takes the brain model and adds the idea of endless cycles of creation and destruction. In this model, the universe doesn't just begin with a single Big Bang and expand forever. Instead, it undergoes cycles. Imagine the universe as a bouncing ball. It expands, contracts, and then bounces back to expand again, creating a new universe each time. After each cycle, the universe is slightly different, with different properties and possibly different physical laws. This endless process suggests that every possible version of the universe could be realized over time. So, even though we think of our universe as a unique event, the cyclic model suggests that it's just one phase in an eternal loop of universes coming and going, each with its own characteristics. The landscape multiverse is another concept rooted in string theory. String theory predicts that there are many ways to configure the extra dimensions it proposes. Each configuration represents a different universe in what physicists call a landscape of possible universes. Think of it like a vast desert with countless sand dunes, where each dune represents a different universe. Some dunes are stable, meaning they correspond to universes that can last long enough to develop stars, planets, and life. Others are unstable and might collapse before anything can form. This landscape is so vast that it's believed to contain every possible variation of physical laws. Some universes might have strong gravity, others might have completely different particles. The sheer number of possibilities in the landscape multiverse means that our universe could be just one small region in this enormous desert of universes. The quantum multiverse is perhaps the most intriguing and widely discussed. It's based on the many worlds interpretation of quantum mechanics. In this model, every decision, every event, and every possible outcome creates a split in the universe. Imagine standing at a crossroads. Every time you make a decision, the universe splits into branches, each one representing a different outcome. If you choose one path, there's another universe where you chose the other. This branching happens constantly at every level, from the quantum scale to everyday decisions. The result is a multiverse where every possible version of you exists, each living out different possibilities. In one universe, you might be a successful artist, while in another, you never pursued art at all. This infinite branching creates a tree of realities, each one as real as the others, but they never intersect. It's like a library filled with infinite books, each telling a different version of your life. The holographic multiverse suggests that our three-dimensional reality is actually a projection from a distant, two-dimensional surface. This idea comes from the holographic principle, which argues that everything we experience in 3D can be encoded on a 2D surface. Imagine watching a 3D movie. The images you see seem to have depth, but they're really just projections from a flat screen. In a similar way, our universe might be a projection from a distant surface where all the information about the universe is stored. If this is true, other distinct projections could represent entirely different universes with their own properties. It's a mind-bending idea that turns our understanding of space and reality on its head, suggesting that what we perceive as the real world is just a shadow of a more fundamental layer of information. The simulated multiverse takes us into the realm of speculative science. It's based on the idea that if a civilization becomes advanced enough, it could create highly realistic simulations of reality. If these simulations are indistinguishable from the real world, and if many simulations are created, then it's statistically more likely that we live in one of these simulations rather than the original reality. Imagine playing a video game that's so advanced that the characters inside it believe they're living in a real world. Each simulation would represent a different universe with its own rules, history, and events. This idea raises deep philosophical questions about the nature of reality. And if simulations can be created within simulations, could there be an infinite hierarchy of simulated worlds? The ultimate multiverse takes the idea of infinite possibilities to its extreme. It proposes that every possible universe exists somewhere. Not just variations in physical laws, but every conceivable scenario, no matter how unlikely, plays out in some universe. Imagine every story you've ever heard, every dream you've ever had, and every what-if question you've ever asked. Each one is real in some universe. In one universe, you might be living in a world where humans evolved wings. In another, gravity might work in reverse. The ultimate multiverse suggests that there is no limit to what could exist. Every possible reality is out there somewhere, making the multiverse a boundless collection of every imaginable world. The multiverse theory is highly debated within the scientific community. On one hand, many theoretical physicists argue that concepts like inflation, string theory, and quantum mechanics naturally lead to the conclusion that multiple universes must exist. For them, the multiverse isn't just a possibility. It's a requirement for certain mathematical frameworks to make sense. However, skeptics counter that there is no direct observational evidence for these other universes, which means that, for now, the multiverse remains speculative. The lack of testability is a key issue. Science relies on predictions that can be observed and verified, and no experiment has yet confirmed the existence of other universes. Critics argue that until we have direct evidence, the multiverse concept should remain more of a philosophical idea than a scientific fact. Even within the multiverse supporting community, there are competing hypotheses. For instance, the inflationary multiverse theory suggests that each bubble universe could have entirely different physical laws, but this raises questions about whether such universes could ever be observed or measured. Similarly, the landscape multiverse from string theory proposes that there are so many possible configurations that testing specific predictions becomes nearly impossible, leading some to question whether this is truly science. Quantum mechanics lies at the core of many multiverse theories. The strange behavior of particles in superposition, where they exist in multiple states until observed, has profound implications. The many worlds interpretation takes this concept and applies it on a universal scale, suggesting that every quantum event creates new realities. This connection between quantum mechanics and the multiverse blurs the lines between science and philosophy, raising questions about the nature of existence, free will, and determinism. Philosophically, the multiverse challenges our understanding of what is real. If every possible outcome is realized somewhere, are all these realities equally valid? What does this mean for our choices? These questions are not just theoretical. They strike at the heart of how we perceive ourselves and our place in the universe. Speculative fiction has long been fascinated by the idea of parallel universes. From classic novels like The Man in the High Castle, which imagines an alternate history where the Axis powers won World War II, to movies like The Matrix, where reality is a simulation. The multiverse provides fertile ground for exploring alternate worlds and what-if scenarios. These stories don't just entertain. They make us question how small changes in our choices could lead to entirely different lives. One of the best-known thought experiments that introduces the concept of the multiverse is Schrödinger's cat. In this scenario, a cat is placed in a sealed box with a device that could either kill it or leave it alive based on a random quantum event. According to quantum mechanics, until you observe the outcome, the cat is both alive and dead, a paradox that illustrates the strange nature of quantum systems. The many worlds interpretation takes this idea a step further, proposing that both outcomes occur but in different universes. In one universe, the cat is alive. In another, it's dead. This idea suggests that every quantum event creates a branching pathway where all possibilities are realized, leading to an infinitely branching multiverse. When we consider the multiverse from different angles, quantum mechanics, cosmology, philosophy, and speculative fiction, we see how interconnected these ideas truly are. Quantum physics provides the foundation for understanding how multiple realities could coexist, while cosmology expands these concepts on a grand scale. Philosophy pushes us to question the implications for existence, free will, and the nature of reality itself, while speculative fiction brings these ideas to life in a way that is both engaging and thought-provoking. The multiverse is one of the most exciting and profound concepts in modern science, bridging multiple branches of knowledge from ancient philosophy to quantum mechanics and speculative fiction. Whether these alternate universes are real or purely theoretical, they challenge us to rethink our understanding of reality and open the door to endless possibilities. As we continue to explore the universe and refine our understanding of physics, the idea of infinite worlds remains a captivating frontier in the quest to comprehend the true nature of existence. If you're ready to take your space knowledge to the next level, check out the binoculars through the link in the video description below. As an Amazon associate, I earn from qualifying purchases, but it won't cost you a penny extra. Thank you for joining us on this journey through multiverses. Please like, comment, and share the video, and please do not forget to subscribe for more videos.